Hey there, Ravens. We are back and we are talking about the ideal gas law, and we're going to do some practice problems that are in your notes packet. The ideal gas law, here we go. A sample of hydrogen gas has a volume of 8.56 liters at a temperature of 0 degrees Celsius and a pressure of 1.5 atmospheres. Calculate the number of moles of hydrogen present in this gas sample. Assume that the gas behaves ideally. Okay, for all of the problems you will ever encounter, assume it behaves ideally. You do not have to worry about if it's not. Okay? All right, so we know, let me use my pen here. Okay, we're told in the problem that we have a volume of 8.56 liters. Okay, we have a temperature of 0 degrees Celsius, so that's 273 kelvins. I'm going to write kelvins down automatically. Pressure is equal to 1.5 atms. And we're being asked to find N. Okay? And the other thing that we should write down that we know is we know R. R is our constant, and it's 0.0821 liter atmospheres over mole Kelvin. Okay, and it's always wise to check your units. My volumes in liters, pressures in atmospheres, and temperatures in Kelvin. So I'm good there, and I'm going to be solving for mole. All right, so the formula, how am I going to get there? That's PVnert. PV is equal to nRT. If we're going to solve for N, we're going to end up with PV over RT. And I just start plugging things in. So pressure is 1.5 atmospheres. Volume is 8.56 liters. And I'm going to divide all that by R, which is my constant, 0.0821. And my units, liters, atmospheres over mole Kelvin. And temperature is 273 kelvins. Let's send that line out. Okay, so atmospheres cancels atmospheres, liters cancel liters, and kelvins cancel kelvins. And so the number of moles when I do all of this, let me look at the right one, is going to be 0.573 moles. Okay, and if 1 mole at STP, which is standard temperature and almost standard pressure we have here, is 22.4 liters, I have 8 liters here, so 0.5 moles seems pretty reasonable to me. Okay, so that is the first practice problem, and let's get the arrow back, and we're going to go forward. And here we go. Here's another one. Okay, and we got a warning here. Make sure that your units agree with the units in the constant. Okay, so what do we know? What volume, oh, well, that's what we need to find. Oops, pen. Volume is equal to our question mark, 110 grams of carbon dioxide gas. So that means we're going to need to take 1,100 grams of CO2 and divide it by the molar mass, and carbon dioxide's molar mass is 44 grams of CO2, so that's 16 times 16 equals 32, plus another 12 gives you your 44 over 1 mole. And we end up with 91.7 moles of the CO2. So N is equal to 91.7 moles. Temperature is equal to 25 degrees C. I'm going to automatically add 273 to that. And when I do that, I end up with 298. And my pressure is 371, and it's torr, and I don't want torr, I want atmospheres. And I know it's 760 torr to 1 atmosphere. If you don't remember that, it's in the very beginning of this same packet, the conversion factors for pressure. Okay, so then 371 divided by 760 comes out to 0.488 atmospheres. Okay, so remember, we want moles, we want kelvins, we want atmospheres, and our volume will end up being recorded in liters. All right, how do we get there? PIVNERT. PV equals nRT. So volume is going to be equal to nRT divided by P, because that's what we had to pull out. So number of moles is 91.7. And R is 0.821 liter atmospheres per mole Kelvin. Our temperature is 298 kelvins. And we're going to divide by a pressure of 0.488 atms. Okay, looking at units, mole and mole cancel, Kelvin and Kelvin cancel, atmosphere and atmosphere cancel, and the only thing left is liters, which is my unit for volume. And we end up with 4,597 liters. That's a 9. Huge number. We also had 99 moles. Okay, 1 mole at 1 atmosphere is 22.4 liters. Okay, so the fact that I have almost 100 moles and I have about a half of an atmosphere, then that seems about right. That looks good to me. Okay, this is the end of the practice problems in the homework in the packet. You do have some homework problems there, so the next video in the series will be the ideal gas law homework problems. Okay, see you soon.